welcome back to my YouTube channel. And today we will be discussing Kafka. So, in my previous videos, you have heard me saying about messaging queues using here and there for scalability, for performance purpose, for many purposes. You have seen me saying that we'll use a message queue, and most of the time we use Kafka. If you see in the market, Kafka is highly used, and it is the first choice when we are building a very highly scalable system. So in this video, we'll discuss the internal workings of Kafka, why it is so scalable, why everyone prefers it, and what problem does it solve that other messaging queues are not able to solve. Okay, so let's get started. So let's suppose there's a messaging queue where you are consuming through a consumer from that queue, and let's suppose there are n number of instances of that consumer. Okay, so what will happen is, let's suppose there are three messages. Okay, M1, M2, M3. Okay, so this you'll push three messages at same time. So this M1 will pick the first instance, second instance will pick M2, and third will pick M3. Okay, and all three will be get consumed. So as soon as these three consumers mark them as acknowledged, it will be not found in queue and neither in consumer. So this message is not saved anywhere. Okay, so let's suppose this is okay till now if you have only this behavior. But what if these three messages I need to consume by some other consumer from another service? So no, it is not. We cannot do this because this queue will not have that message once it is consumed. Okay, so this is the point-to-point queue structure where these are the limitations. It is very straightforward. You'll push a message in the queue. That queue will push that message into a consumer, whichever is free at that point of time, and that queue message will be gone. Uh, so let's move on. If we have multiple cases, like multiple consumer consuming from that queue, and also this queue is a single point of failure. So how Kafka helps in solving all these problems. Let's see how does it do that. So this queue is so Kafka also has queues. So Kafka doesn't have queue; it has topics. It works on publisher and subscriber model, so it has topics. So subscribe some, we publish some message in that topic, and that message is subscribed to consumers. And there's one coordination service. Usually, Kafka uses Zookeeper to keep track of that which consumer has consumed till which all messages. Uh, so since messages are not deleted here in topics, so coordinator service need to take care of the offset till which that consumer service has consumed. Let's suppose there are three messages again. We'll take this example, and also we have taken this example, and also let's one M1, M2, M3. Okay, and and let's suppose it has offset 0, comma 1, comma 2. So these three offsets are there here. Okay, so M1 has 0, 0th position, M2 is first, M3 is second. So let's suppose M1, M2 is being consumed by consumer, and consumer goes down. So this coordinator service will know. Okay, so you have consumed till 1. Now I'll start giving you message from 3. Okay, so this is a way how it works, because message is not deleted. So in the topic, message is always there. So now you'll be wondering, if message is always there, it is saving that message. It must be using some database. Now comes to database part. So if you see that in this topic, millions of messages being published, and these messages are read by consumers at same pace. So no such database exists that solves this problem at this scale efficiently, where we need high writes and high reads. Okay, so what Kafka does, it saves messages in a file, and that file is saved in a disk. So let's see how a message looks like. So this is what a Kafka message looks like, where it has key value pair. We can also send it in form of protos. If you know about gRPC, I'll create a different video on how RPCs work, how protos works. Okay, so it has headers, it has partition offset of that message when it is consumed by consumer. It has an ID and timestamp. Okay, so now how Kafka saves that message in a file. So the Kafka saves message in a file in an append only mode. Okay, so since it is being appended, so you must be thinking that if a file size, let's suppose it keeps on increasing every moment. So how will you manage that? So what we can do here is we can do some kind of set some kind of configurations like let's suppose we can do it based on size or time. Like if size of this file becomes this much, then create a new file. Okay. If or we can say that if we write all the messages of a particular day in one file, as soon as the date change the file. So like this, it creates file and it calls it these files as segments. Okay, so these segments are written in append only mode. The segment which is being written is called active segment, and the segment which has already been written is immutable now and called inactive segment. Okay, so this is all index. So it also helps us to delete things like every topic has one retention policy. It will never keep message forever. Okay, you should give a retention policy here, like delete this message after this period of time. Let's suppose we are deleting after 1 day. So 1 day's message is inside one segment. So after we delete that segment completely, it doesn't need to search. Okay, so like this, we can optimize things here. Uh, Now moving on to problem. Let's suppose the second problem which we face in that point-to-point connection is that one queue was only consumed by one consumer. But now, since that topic is saving messages, so you'll say that let's suppose I want to consume it. Consumer one is consuming, and I want consumer two to also consume. No, it is not. It doesn't work like this straightforwardly. You can do this, but in a different manner. I'll tell you how. So every consumer has its consumer group where let's suppose this is a consumer group and it will has multiple instances of this consumer. Okay, and since there are multiple consumers, we are also dividing topics in multiple partitions. It is same as we are doing sharding in database. Okay, where we keep different data in different charts. Here we are keeping different messages in different partitions. So what we can do is for scaling, let's suppose the problem here one more was if millions of messages consuming and your consumer is only consuming 10 messages a second, so you will not be able to consume these many messages and it will generate a lag. And so what we did is what we did it like we created multiple instances of consumer and these instances started consuming from different partitions. So now if there are 1 million message, half million will in partition one, half million will be partition two, and this consumer will consume half that million and another will consume another half. Like this, we can scale it furthermore. We can create more partitions and more consumers. Just be sure that these are consumers. If a consumer inside a particular consumer group, so this consumer, if it is consuming from this partition, so messages of partition one cannot be consumed by consumer second instance of that consumer. So this cannot happen. This cannot happen. Okay, but let's suppose if our consumer is consuming very fast. We have created partitioning. Then also this can happen. Okay, so a particular consumer can consume from multiple partitions of same topic, but a partition of a particular topic cannot push message into same consumer. Two different, same topic cannot consume send message to different consumers. So this cannot send message in both of these consumers instance. These consumer instance are of same consumer. Okay, so understand, consumer is like a service. We have created multiple instance of that. Okay, so this can be done like this instance is reading both, and we can delete this. So, in easier words, if there are n partitions, we cannot have more than n consumer instance, because one consumer will always be an idle. More than n will always be idle. Okay, so like if there was only one partition, so this will always be idle. This consumer is not never consuming. It's waste of resource. So make sure that this is not happening. Now comes to different consumer groups. So here, what we are doing is, let's suppose an order is placed by an user. Okay, so that message comes inside our topic one, and our order. Let's suppose this is consumer group one has order consumer, where we want to do n number of things when an order is placed by an user. So this consumer is doing that all things. But what if user service says, hey, I also want to perform some operation. I want to divide my users in some particular segments. Or let's suppose I want to give them extra discounts if he has ordered a pretty good amount of order he's doing. I want to mark him as a grade A user. Any operation, if user service want to do on order creation, order placement, so that consumer group, we can create different group, and that user consumers can come inside this, and it can start consuming from partitions. So with this problem was not getting solved in point to point. Okay, but now different consumer services can consume from same partition topics. So I mean same topics and same partition. Uh, just that we have seen here, from a particular partition, no two consumer can consume if they are inside same group, but if they are inside another group, they can consume. Okay. So moving forward, now you say that, oh, okay, if this partition is down, what will happen if this partition is down? Fair enough. We are not. It can become a single point of failure, because let's suppose this consumer is only dependent on this partition. It will only listen from this one. Okay. So what we'll do? So these consumer groups come inside a broker. Okay, so what broker is? Broker is just suppose broker as when it's it is used for replication. Okay, so we can have different brokers, and same partition replication can be created inside different broker, and we can have leader, topic partitions, and followers. I'll explain you in detail, don't worry. Let's suppose there are two broker here. Okay, there are two broker. Okay, broker one and broker two. So this broker has leader of partition one. This broker has leader partition two. So this partition one is follower. This partition two is also follower. So message is always consumed from leader partition. Okay. So this consumer group will be consuming messages from this leader, and also from partition two leader. Okay, so it will be connected to multiple brokers, which is common, which is okay, but it will only consume from leader. These two follower partition are just for the sake of data replication, because let's suppose if uh, leader goes down, consumer can start consuming from its follower. Okay, and we remember the offset is based upon how much that consumer has consumed. So if till message to this partition has was okay, so if it goes down, then that message three will be in follower partition also. Now consumer can come and start consuming from partition one follower, because it will be elected as a reader. Okay, so it works same as we have seen in key value databases and all. It is same. It is working same manner. When a message is pushed inside inside a uh, topics partition, so it is only said that done only if n number of followers have saved that message properly, like we were doing in key value pair databases. Data replication. This is how data replication works in every system where we allow to allow. Let's suppose there are three followers, but I'm saying if my two followers have saved that message and leaders have saved, it's okay. Okay, so like this, we can create different brokers, different consumer groups, different consumers. We can create a number of topic partitions. We can create multiple topics. Multiple instances of consumers can be there. Like this, Kafka can scale how much we want to scale it. Okay, so I I think that's too much. You can review, go back in my video and see again if you've not understood anything. This is pretty complex. It is not that straightforward, but it is very useful for you to understand how Kafka works. If you want to work on Kafka, this will really help you. How internally they are doing so much good. Okay, I hope you like this video and this video gives you a great value. Uh, so yeah, keep watching me. Do let me know if you want me to create a video on any other topic or uh, any other system and concepts. I will be very happy to do that. Till then, take care.